Hi, this is a demonstration of using LupinPet for performance predictions. What we're looking at here is a trace of basically a three-tier Oracle application. The front-end tier is between a user and an IIS server, and then the back-end tier is between that IIS server and a database server. If we look at the conversation display here, we see there's two conversations going on, and it's really just showing the two conversations between the two tiers, between the user and IIS, which took a total of 0.095 milliseconds, and between IIS and database server, which is a lot faster. We see it actually had a duration of 22 milliseconds. To get a better view into what's going on in those conversations, let's look at the turn analysis. So again, we see the initial conversation between the user and the IIS server. Here, I'll just color code that. Between the user and the IIS server, so again it's between the user here and port 80 on the IIS server. We see there's a initial request, a delay of 74 milliseconds, and then a response from the IIS server. And during that delay, you see the back-end processing going on here between IIS server and the DB server, and there's actually, what do we got, 6 turns there. To use this for performance predictions, we go over to the Performance Prediction tab, and first thing we need to do is decide which tier we want to perform performance predictions on. So let's start off by just pretty much making it a best case environment, 100 megabits per second network connection between the user and IIS, no latency. We'll calculate and we see the results, and this shows a comparison between so traces for the total trace. The original was 95 milliseconds, our prediction is 91 milliseconds with these connection parameters here. So it's a little faster than the original. That's probably because we weren't really reaching 100 megabits per second during the actual taking of the trace, but it's close enough to make us feel fairly comfortable that the prediction's in the right ballpark. Let's try some things. Let's reduce the front end bandwidth to 1.2 megabits per second, still no latency, recalculate, and we see now the difference between the original and the prediction. The original was 95 milliseconds, we're now up to 1.5 seconds for that transaction to complete, and that's due to this restricted bandwidth on the front end. We also attempt to put restricted bandwidth on the back end. Let's calculate again. You see it's extended the time it takes for the back end to 0.337 seconds, and if we compare between the original and the prediction, especially at the tier layer, we see that the tier and the back end got extended, so the total trace time got extended to 0.409 seconds. Usually with database transactions, if they're very chatty, latency in the back end is going to have a greater effect. So let's push up the back end latency to 50 milliseconds. Still the same back end bandwidth. Recalculate, and we see now that the tier delay in the back end's gone up to 0.637 milliseconds. This is even more pronounced if you have more turns in the back end. So let's look at this trace here. Okay, let's color code the port. So again, we've got a front end transaction, and then basically I think 100 SQL transactions, SQL turns that happen in the back end, and you can see down here in the decodes it's a select for the same thing 100 times. Just kind of not what you normally do, but example of probably a badly optimized back end in this case. This time it's MS SQL instead of Oracle. If we go into performance predictions and try the same calculation, we see the back end, because we've got 50 milliseconds round trip delay, we've got 100 turns. It's extended the tier delay from 237 milliseconds up to 11.489 seconds, and this is kind of an example of what you frequently see in production, where back end servers are moved apart. Maybe they were co-located in a data center and moved across the country. So there's a quick overview of the performance predictor. Things to note about it is it is a prediction, so some of the the assumptions about the way the traffic's working and how the tiers are using the traffic are just that, assumptions. Most cases for well-known protocol it's going to work okay, but just be aware that it is a prediction and you should double check the results. Usually I'd do a actual network simulation through a WAN emulator as well to double check some of these results, but there's a good quick way of seeing what the impact of latency and bandwidth is on tiers, especially for well-known protocols where you know that the tier interaction is sequential in nature. You'll actually get a warning here if there's more than one tier involved in the transaction, just letting you know that the estimate may be less accurate. So if we look at some of these simpler transactions where this is just a straight HTML page with 3 resources and we don't get the warning, but it's only one tier, and we see the impact of probably bandwidth mainly in this case, seeing there's only 4 turns on the result, and that's probably because of the size of this turn here, where it's trying to move meg of data across the network. We set our predictor to 1.2 megabits per second, so basically it's going to extend it by close to 8 seconds, and that's kind of what we're seeing in the predictor.